Hi everyone, welcome to this video, and in this video I'm going to give a short update on my handheld game console, which is Monoretro, on which I've been working for past several months. So for my next upgrade of Monoretro, or rather for my next build of Monoretro, I am going to replace these control buttons, that is the buttons which helps us move the character left, right, up and down, with a PS2 joystick. Yeah, so I've decided to get rid of these buttons and use a PS2 joystick in place of these. So I feel like for me personally, I enjoy using a joystick. Like whenever I'm using a game controller or anything, like I love using joystick, and also this managing these four buttons takes up a lot of space. Basically the functions of all these four buttons can be replaced by a single joystick, right? And the joystick will also act as the fire button, because the joystick comes with a button as well, right, on which you can press. So that will remove this fire button as well. So right now, like let's say if I play Space Invaders, this is the fire button with which I can fire, and so this button will also go away. So this button I use it only as a fire button. So in games which will have a firing option, that will usually use this button, but this will also get replaced by the joystick, right? And so the only button that will remain is the select button, right? So because I need one button to select stuff and get out of games and those kind of things. So let's say I'm inside a game, let's say I'm inside bricks, so I need one button to cancel that game and get out of it, right? So for that we'll keep the select button, or the selector button, whatever, and of course the switch shall be there, the power switch shall be there. So now of course I can't modify this build on the fly to add the PS2 button, so I won't be touching this console, but or rather this version of the console, or rather I will be using my staging setup, the setup that I have on a breadboard with all those breadboard wires and everything. So I'll be using my staging setup to test out the PS2 button and how it works out, to test how it works out with the existing setup, right? And so how we can use it instead of all these four buttons. So yeah, that's what I'm going to do in this video and test it out. Okay, so the PS2 joystick that I'm going to use for my console, it looks something like this. So it's a classic PS2 joystick, and it comes with five pins. 1 2 3 4 5. Yeah, it comes with 5 pins. So one pin is for ground, the pin at this edge is for ground. Then comes the VCC, or the 5-volt supply pin, right? And then comes the two interesting pins, which will basically allow us to track the x-axis and y-axis movements. So the pin right after the VCC pin is for, or rather the third pin from down is for tracking the x-axis movement, right? It's the VX pin. Immediately after that comes the pin to track the y-axis movement, and the last pin is the pin for the switch, which comes inbuilt with the PS2 control, the PS2 joystick, right? So that's for the switch. So usually how this works is like this is the y-axis. So when the pins are pointing towards the left, this is the y-axis and this is the x-axis, right? Or the horizontal axis and the vertical axis. So how it essentially works is, I mean nothing different for how the switch works. You just assign a pin to this switch and its pull-up configuration, and you check and you do a digital read on that particular Raspberry Pi Pico pin to whichever pin you are attaching this PS2 joystick pin to. You do a digital read on that pin and you get the value. If it's pressed, then it's 0, or else it's 1, because it's a pull-up register configuration. The interesting part is how the VX and VY work. So this PS2 joystick basically comprises of two potentiometers, right? One for the x-axis and one for the y-axis. So we essentially have two potentiometers. Now a potentiometer will give you analog values, right? It won't give you digital values, but it will give you analog values. So the thing we need to do is, we can't connect these two pins, these two like VX and VY pin of the PS2 joystick to just any random pin of the Raspberry Pi Pico, right? we need to connect them to ADC pins, or rather pins which have a ADC. See, that is a analog to digital converter, right? So good for us. The Raspberry Pi Pico comes with 4 pins, which has got a ADC converter, and the ADC that Raspberry Pi Pico provides is a 12-bit resolution ADC. That is, it would map the analog value to a value between 0 to 1023. So that's pretty much how the ADC would work. It will take analog signal from this x-axis and y-axis, and it will convert it to a digital value between 0 to 1023. We'll stick to these 4 pins, and rather actually we won't be using all the 4 pins as well. We'll just be using 2 pins because we just want x-axis and y-axis value. And now how do we, so in a moment I'll show you the code that I'll be using to track up, down, left and right movement with this joystick. So since I said that the maximum values, that the total range of values that this joystick can have is like 0, like if I move it all the way towards left, so it's 0, the pin will read as, the pin output will be 0 to 1023 to extreme right, and from 0 to the 0 at the extreme top to 1023 again at the extreme bottom, right? So when you are not touching the joystick, so roughly the value it will give you is somewhere around the middle of this range, that is 511ish, right 511ish. But we will have to come up with certain thresholds, like we need to come up with thresholds, like if the value is above that threshold, then we are moving right or down, and if the value is below certain threshold, then maybe we are moving left or up, right? So that thresholds we'll have to decide. And yeah, that's pretty much it how this PS2 joystick works. And so let's see the temporary setup that I've created on my staging environment, or like my breadboard environment, and let's see how the connections have been done. Okay, so this is how the connection looks like. It's a bit difficult to follow on the breadboard setup, but I'll try to explain it as nicely as I can. So here I have used all the pins of the, let me just pull the joystick towards one side. So here I'm using all the pins of the joystick. Like the first one is ground, then it's 5 volt, then VRX, then VRY, and then the switch. Like all of those are now connected to respective pins of the Raspberry Pi Pico. So these 2 pins that I'm using here, so these two pins, the orange and the white wire pins, so these are for VX and VY respectively. So both of these pins, which is 26th and 27th pin of the Raspberry Pi Pico, both of the pins have a ADC attached to them, and hence I can use them for getting the potentiometer output in digital form. So these 2 are for, so once I use analog read on these 2 pins, I can't use digital read in this case, but once I use analog read on these 2 pins, I will get the corresponding analog value, which is mapped to a value between 0 to 123 from these 2 pins, right? So that's how I'll get the x-axis and y-axis values. And the switch pin which is SW, that I have connected to the pin of the Raspberry Pi Pico, which I was using for fire pin. So nothing different here. I just disconnected. So this was my original fire pin on my staging setup. I disconnected it, and instead I replaced it with the PS2 joystick's switch pin. So now when I'll press this, I'll get the state of the fire button by doing a digital read on the old fire pin, because now it's connected to the fire switch of the PS2 joystick. Yeah, so that's the setup. And the ground I have connected to the common ground, and the VCC pin I have connected to the output of the Raspberry Pi Pico, the voltage output of Raspberry Pi Pico. So that's pretty much it. It's a pretty simple setup. Now let's look at the code once, how it works at the code level. So the code is pretty simple, not much of a change, but I'm just changing how I'm reading input for the left, right, up and down buttons, or rather I should say joystick movements. So rather than dropping the support for buttons completely, what I decided to do is I have added so if I go to common.h, which contains all my constants, what I have done is I have added a macro called use joystick. So when its value is 1, I'll be using the joystick instead of the buttons for left, right, up and down movements. So what I've done is, so since now there are 2 different input methods, so button as well as joystick, and of course I'll be using one at a time, but I can't use only digital write. So instead of directly doing a digital write on the pins, which I used to do, like in, let's say for example in Space Invader, so earlier there used to be just digital read on up and down pins. Instead I have created two functions, but basically I have abstracted the input operations inside these four functions: right, left, up and down pressed functions. So let's see how these functions work. So I have created four functions: is up pressed, is down pressed, is left pressed, and is right pressed. So up pressed and left pressed works similar way, and down pressed and right pressed works again in the similar way because the values are similar. So let's take the example of is up pressed. So remember, like if we are not touching the joystick and we just leave it at its middle position or its stable position, the value that the potentiometers will read is somewhere around the middle of the range 0 to 123, which is somewhere around 511. But we can't directly use the value 511 because it's almost the exact center, and there will be some jitterness if we use that value. So you might see some bad input state if you use exactly 511 or 510, 513, that small window of values. So we don't want that jitterness. We want to have a smooth experience where when the player moves the joystick up or down, only then the impact should happen, right? So let's say if you want to move the Space Invader character left or right, the user should be able to move the joystick completely to left or completely to right to get the proper impact of moving the character left or right. There should not be any jitter or jerky movements. So what I've done is, like, the first condition I'm checking is if use joystick equal to 0, which means joystick support is off, we simply do a digital read on the up pin. But this is not the case we are interested in. If joystick support is enabled, what we do is we ignore the button and we try to do an analog read on the vertical pin, right? So the vertical pin is 27 and horizontal pin is 26, and both of these are ADC enabled pins. So if the y-axis value is less than 200, right? So it's towards the upper half of the range. By upper half I mean actually it's towards the lower half of the range. Like if it's 0 to 1023, it's towards the lower side of the range. So if the value is towards the lower side of the range, that is less than 200, that is the user has really moved the joystick up along the vertical axis, then we return 0. Why 0? I could have done 1, but the convention that I have been following so far because of pull-up registers is if something is pressed, it's 0 or else 1. So here too I am just using return 0 if someone has actually moved the joystick up. Similarly in is down pressed, we just revert the situation or inverse the situation. So again you can ask me why it's 200. I kept trying various different thresholds. I started with 510, went down to 500, 300, but still there was some sort of jitter, so 200 seemed to be a pretty nice threshold, right? Similarly for down pressed, 600 seems to be a pretty nice threshold. This means that the user has really pulled the joystick towards the downward direction along the vertical axis, right? And if that's the case, just return 0 or else return 1. 1 means user has not moved the joystick down, right? So yeah, pretty simple. And the conditions are exactly same for left and right, because along the x-axis as well the range is same, 0 to 123. If it's less than 200, it means if the horizontal pin value read using analog read is less than 200, it means the user has really pulled the joystick towards the left hand side. And if it's greater than 600, it means they have really pulled the joystick towards the right hand side, right? And accordingly we get the value, we apply the threshold, and we decide whether it has been moved or not. So accordingly we return the values, and in all the places where we were doing a digital read on the pins, what I have done is I have just simply replaced them with is right pressed, is left pressed. Similarly I have done the same in break.ino, and I have replaced, and even on Pong I have replaced it with is up pressed and is down pressed. So that's it, pretty easy, right? And also the other place where I have changed is the menu selector when I am just moving up and down the game menu list, and there as well now I am using is up pressed or is down pressed. Yeah, so simple enough. And now let's see how it looks like when I use it on the staging environment and how it looks on the display. So here we are once again to our breadboard setup. And one thing I would like to mention here is like there might be some sort of jitter on the screen because there is just too much wires at this point on the breadboard, and there might be loose contacts and stuff, as a result of which there might be jitters on the screen. But still, I'll try to give you a nice demo of how this looks like in reality. So let me just give the connection. So there we have it. The splash screen is on, the console is on, and now so again, when the pins are facing left side, so this is the x-axis and this is the y-axis, right? So let's check. So first I'll go to the menu screen, right? So now I am on the menu, and now I can, let's see if I can select I can move up and down using the joystick, and it works. I can, if I move the joystick down, I am able to move down and I am able to move up. So it works. The threshold is working, there is no jitter. Now let's play Space Invader, right? So what I'll do is I'll simply select Space Invader, and it says press fire. Let me press the joystick switch. Yep, and I can move the character left, right, all using my joystick. So, and let's see if I can shoot while moving. I can shoot as well. I can move and shoot, and that works pretty smooth actually. I know it's a bit difficult to see. I'm recording on my mobile, but I hope you are getting the overall idea of how this is behaving. It's behaving pretty well, and I am able to move left, right, and I am able to shoot as well, and it feels really great. Like I'm able to control the character on this tiny screen with this joystick, this PS2 joystick. Yeah, so that's pretty much it. That's what I wanted to. That's the update I wanted to speak about. I'll be creating a new version of Monoretro. I might even consider an alternative to Raspberry Pi Pico, because I'm trying to find a microcontroller, or rather a microcontroller board which is even smaller than the Raspberry Pi Pico board. So let's see what alternative I can come up with. But in the meanwhile, I wanted to try out a PS2 joystick instead of the push buttons, and yeah, I'm happy that it works really decent. So yep, that's it for this video. I hope you all liked it, and see you all next time.